Exception handling is a really useful skill to add in as soon as possible, which is why I'm sticking it right near the start of this course as our kind of our first real new topic that you haven't covered in grade 11 at all. And the purpose of exception handling is to be able to deal with situations where errors in the running of our code, not in the actual creation of it, like our code might all be secure and written well, but that some changes that might happen while the program's running might actually crash the program. We can avoid those things. The most common example of this would be if a user inputs some data, because if you're expecting an integer and they put in a string, things might break. Or if they type in a value outside of a range you're expecting, you might have to kind of narrow them back into a certain range. Or maybe there's some type of thing that's not the right type that you accidentally send somewhere. You can build a structure of handling exceptions so that if the wrong type of data ends up in a certain spot, your program doesn't get completely confused and crash. Instead, it knows how to kind of push it to the side or stick it somewhere out of the way so that the program can keep running. So the main reason for this is to prevent crashes during our program's runtime. And I want to offer you a metaphor to help you understand kind of what's going on before I dive into some specific coding lessons of how to implement it in both of the languages. In Java, we call, the framework of our exception handling is this term, try, catch. And in Python, the main idea is similar, but we say it's try, except. So kind of the core metaphor going on in this is try to do something but catch any problems. And maybe you want to imagine the idea of having someone standing in front of a window while there's people playing pass and someone hits a ball, and before that ball smashes the window, someone catches it before it can smash it so that the problem is avoided. And in Python, maybe the core metaphor here is try to do something except if it's going to make things go terribly wrong, and then you should probably do something else. It's kind of like conditional logic. It's just a bit of a different way of framing it around different ideas. So here's what I want you to think about. Ever seen those viral videos on YouTube or on TikTok where people are trying to do a cool trick? Maybe you have like this path that people like to walk down with a staircase, for example. Oh, my stairs are getting pretty jagged here. Down to a road. So this here is an actual road that cars drive on. Love my art, I hope. And we have this awesome railing that goes right down to the sidewalk over here. And there's some cool tricks. So we've got somebody who might be on a skateboard of some kind, this beautiful stick-figured person who wants to just go for it and launch themselves into a sweet grind or do some kind of cool trick. Maybe they're trying to jump over the whole staircase, right, and do something awesome, something super impressive that's being filmed by their friends, maybe down over here, who like have their phones out and they're recording. Why are they facing backward? That should be their hair at the back. I don't teach art classes, don't worry. So they're trying to film this cool trick, and the problem is that the problem's not with the skateboarder, because maybe they're super proficient. Maybe they're actually pretty awesome, and they're able to, as they travel, actually perform some sweet trick where their board's upside down in the air and they're holding onto it with one hand, while the other hand is like, I don't know, doing something sweet, and they perform this sweet trick and they land down here, and they're just like super triumphant, all right, and here comes the car. And the video finishes with them landing and they're cheering and they get smoked. And now they're in trouble. It didn't matter how awesome their trick was. They weren't careful enough with kind of the result and kind of how the outcome of everything, what went along. Like, it's not just about the trick itself, it's about kind of the result of everything that's happening in the whole system of the trick. And because they weren't careful enough, they got smacked by this car, and everything did not turn out very well. So how could this be avoided? Well, what if you had another friend kind of off in the background here, maybe standing on something kind of nearby, keeping an eye, they're watching the road so that they can keep an eye on if any cars are coming. And they're ready to go, whoa, stop. They like throw something out in front of the person, or they just shout. Maybe I'll do a speech bubble. Let's do this. Speech bubble. Stop. And this person grinds to a stop before they reach this grind here. So this guy watches, there's traffic coming, yo, stop. This person wants to be focused on doing their trick. But when they have a helper that can call out, hey, stop, maybe they can slow down or bail on their jump before they get hit by this car, which then allows them to maybe kind of like go back to the start and then try again. And if the car's coming, they have to stop again. So stop, go back, keep on trying until maybe there's no traffic, and then go right ahead and they can do the cool trick and they can not die. That's a great outcome. But it requires there being some kind of a monitor or a system in place that can catch any issues or can anticipate and recognize exceptions to redirect traffic around, to make sure that the path this logic is taking doesn't continue when there's clearly something that's going to break the code or kill the person coming up next. So the idea is anywhere where there could be some logic that plays out that could break our program, we want to surround that code with try catch or try accept exceptions to handle the terrible problematic outcomes of our program crashing and avoid them by providing different routes and directions and instructions for how to deal with those things. I'll show you some more about how we can do this in our actual code coming up next, but please do seriously consider helping your fellow man from getting killed by writing exception handling code in your code base. See you in the next one.